Well, hey there, Savage Sullivan fans. Are you here to learn how to factor by grouping? Well, you're in luck, because that's what we're going to do today. So here we have the polynomial x cubed minus 2x squared plus 5x minus 10. So as we know, there are a lot of ways to factor. But I see that this polynomial has 4 terms. So automatically, my head is going to the fact that I'm probably going to have to factor by grouping. So, as always, when we factor, the first thing we want to look for is a greatest common factor, or a GCF. But when I look at all of these terms, they don't have a greatest common factor. There is no number or variable that goes into all 4 of these. If this 10 had an x on it, then yeah, we could pull out an x. But it doesn't, so unfortunately, there is no GCF. So that means we're going to go straight to factoring by grouping. So what's nice about this polynomial is I can kind of see in my mind here that these are already written in order that we could group them. We don't need to rewrite the polynomial. So I'm going to go ahead and I'm going to group these 2 terms together, and I'm going to group these 2 terms together. Now, what we're going to do is take a look at each set of parentheses and pull out a greatest common factor from that parenthesis. So when I think about x cubed and negative 2x squared, I know that I can pull out x squared. I can pull an x squared out of x cubed, and I can pull an x squared out of negative 2x squared. But I can't pull any whole numbers out other than 1. So that must be my GCF. So then inside of a set of parentheses, I'm going to put what's left after I pull out that x squared. So after I pull out that x squared, I'm left with x minus 2. Now you might be wondering, how did I get that? Well, x squared times x is going to get me x cubed. X squared times negative 2 would get me my negative 2x squared. Okay, this is what's left over after I pull out the GCF from each of these terms. So then we move and do the exact same process to this set of parentheses. So when I look at that, what is the greatest common factor that I can pull out of 5x minus 10? A positive 5. Now, when I pull the positive 5 out, what am I left with on the inside? What are my leftovers after I pull a positive 5 out of here? We're left with x minus 2. Again, I can check because 5 times x is 5x. 5 times negative 2 is a negative 10. Gasp! Something should be standing out right away. The fact that our 2 parentheses are duplicates of each other, and that's intentional. You know you did your factoring correctly if they came out to be the same. That's what we want. So now we're left with this big old thing here. So when I look at that, I'm going to take my greatest common factor out of this whole thing, or the duplicate parentheses, because this term and this term have x minus 2 in common. So I'm going to take the x minus 2 and I'm going to put it out front. And then what's left over, my x squared plus 5, that's going to go in its own set of parentheses. So when I'm done, my complete factorization is x minus 2 times x squared plus 5. Nice. Take it away, Mrs. Sullivan.
Nice work, Mrs. Savage. That was epic. Wait till you check this one out. See here? We have another polynomial. Again, we've got 4 terms. Again, the very first thing that you should do is look for a GCF. I am noticing that the first 3 terms have an x, but the last one doesn't. So x will not be a part of the GCF. So now I just need to look at the coefficients and decide, does 24, 18, negative 12, and negative 9, do they all have something in common? You bet they do. They all have a 3 in common. So I am going to factor out my GCF of 3. When I take a 3 out of 24, left behind will be an 8. So I've got 8x cubed. When I take a 3 out of 18, left behind is a 6. Don't forget about the x squared. When I take a 3 out of negative 12, left behind is a negative 4. Don't forget about the x. And then a 3 out of negative 9 will leave behind a negative 3. Awesome job. There's a chance that we could be done at this point, but we need to double check and see if we can factor this polynomial here by grouping. Now this 3, this GCF of 3, that's just going to continue to follow down until the final answer, so we cannot forget about it. But we want to put a parentheses around 2 of these terms. So I've got the 8x cubed plus 6x squared minus 4x minus 3. Oh boy, I put that bracket way far away, didn't I? We need to group these here. I'm going to put the first 2 terms together and the second 2 terms together. Just like Mrs. Savage did, we need to decide if or what the GCF is in each of these individual respective parentheses. So again, this 3 is going to come down for part of our answer. I'm just going to use brackets here, so I'm keeping my parentheses clear. The GCF in the first parentheses, I know that 8 and 6 both have a 2 in common, and I see that this is x cubed and this is x squared, so they both have an x squared. Left behind would be a 4x and a positive 3. Then I need to look at this parentheses. Okay, well, they both are negative, but other than that, I don't see anything that they have in common. So I'm going to take out a negative 1. Left behind is a 4x plus 3. Oh, all right. I'm so glad that this worked out because we see that our parentheses have matched. So that's great. We know that this 3 one final time is going to come down for our final answer. The parentheses that match, that's going to be one of the parentheses in our final answer. And then everything outside of the parentheses is also going to be in our final answer. So we've got the 3 from the GCF, our matching parentheses that we found, and then the 2x squared minus 1 from outside, those mini GCFs, for our final answer. If you wanted to check, you could multiply these 2 binomials together and then multiply every term by 3, and you would get your original problem. If you found this video helpful, please like and subscribe.